Somewhere on the distant edge of our solar system, far beyond human eyes, lies a mystery that has eluded scientists for a century. A growing body of evidence suggests a giant planet is hiding in the dark. Planet 9 is a sphere of ice and rock. If current mathematical estimates are accurate, it has double the diameter of Earth and 6 times its gravitational weight. While most planets operate on a flat plane, Planet 9 is significantly off-axis, tilted at a 16-degree angle. It operates at an extreme distance, 500 times the span between Earth and the Sun, taking 15,000 years to complete one orbit. We have mapped distant galaxies and charted the observable cosmos. Yet a world of rock and metal may be hiding in our own backyard, entirely undetected. This creates natural skepticism. If a giant planet is out there, but our most powerful telescopes cannot see it, how do we know it's there? Identifying Planet 9 requires a mathematical lens, studying the effects of gravity to track an object that remains visually hidden. To find this modern ghost, we must look at the framework used to find the last hidden planet in the 19th century. In 1781, William Herschel discovered Uranus. As astronomers tracked the seventh planet over several decades, they noticed its path was erratic. At certain points along its orbit, Uranus would speed up, then slow down. This diagram illustrates what happens when a smooth orbit encounters an anomaly. Objects in space do not alter their speed on their own. When a planet wobbles, an unseen external force is pulling on it, a phenomenon known as a perturbation. By 1846, Urbain Le Verrier and John Couch Adams determined that a planet further out in the solar system had to be responsible for pulling on Uranus. They used orbital mechanics to calculate the exact coordinates where this mystery object had to be located. Over in Germany, astronomer Johann Galle took those equations, pointed his telescope at the precise mathematical location, and within just a few hours, he spotted Neptune. Astronomers tried to repeat the process when they noticed a supposed wobble in Neptune's orbit, leading to the discovery of Pluto in 1930. However, Pluto was far too small to influence a giant like Neptune. This was a case of observational bias. They found a bright object and attributed the gravitational anomalies to it, even though the math didn't match the scale. Neptune's wobble turned out to be an error in measurement, but the method was proven. Randomly pointing telescopes creates false positives, while analyzing gravitational math reveals hidden worlds. Out past Neptune lies the Kuiper Belt, a ring of billions of ice and rock structures stretching across the deep solar system. In 2016, Caltech astronomers Mike Brown and Konstantin Batygin noticed that distant objects in this belt were exhibiting the same symptoms of perturbation once seen in Uranus. This spatial map plots the paths of those distant objects. Instead of spinning randomly, this cluster is grouped together in a specific tilted alignment. Further analysis revealed rocks orbiting backwards, and others looping vertically over the sun's poles instead of around its equator. These repeating patterns point to a gravitational architect shaping the extreme outer edges of our solar system. The Caltech team tested this theory by running a computer simulation of the early solar system. They modeled 2 scenarios, one with Planet 9 and one without it. Without Planet 9, the object scattered, but when the planet was included, the distant rocks lined up with what we observe today. The simulation matches reality with a 99.6% certainty. This creates a contradiction. The outer Kuiper Belt lacks the density of material required for a world of this scale to form naturally. Planet 9 likely originated elsewhere. It may be a rogue planet captured from another star system, or a failed gas giant that began forming near Saturn before being violently kicked out into the void billions of years ago. In either case, the math indicates that a frozen, exiled core is stranded on the outermost edge of the sun's reach. We must consider that these patterns might be misinterpreted. If astronomers are looking for a planet, they may see one in data that has other explanations. The gravitational interference could be caused by a primordial black hole, a remnant from the Big Bang, quietly wandering through our outer solar system. Another possibility is that the laws of gravity laid down by Isaac Newton behave differently at extreme distances from a star. While mathematical models are persuasive, but until we secure a direct image, alternative physics or ancient black holes remain valid possibilities. That uncertainty is about to end. In 2025, the Vera Rubin Observatory begins operation, using the highest resolution digital camera ever built. It will scan the entire visible night sky once every 3 days for 10 years, creating a continuous record of the cosmos. This decade-long time-lapse will reveal anything moving against the static stars. If Planet 9 is there, its motion will be captured. The Rubin survey will decide the fate of this theory. Within a decade, we will either capture an image of the ghost or find that the laws of gravity require a complete revision.